Hi, we'll be giving our final presentation, Optimizing Dexcom Cloud Cost Management. Our client Dexcom is a global leader in continuous glucose monitoring systems. They use GCP for critical operations. The challenges they face is the rising cloud expenditures and unexpected cost spikes. It's important to solve these challenges so they can better manage their budget and improve their operational efficiency. We have three research objectives. First, develop predictive models to forecast future cloud cost. Second, incorporate anomaly detection. And finally, provide actionable recommendations. We have a very large data set, and here's all the attributes. Then we did exploratory data analysis to identify key cost drivers and to understand the spending patterns. The top 20 services by total cost is shown in this plot. And here's the top 20 projects and the top 20 SKUs. We also drew time series plot for the daily total cost. In general, there's an increasing trend in the total cost.
First model that we fit for forecasting and anomaly detection is called Profit. It's a model that's specifically designed for time series forecasting and handle like complex patterns. And it's very similar to the mechanism of generalized additive model. So in our profit forecasting, since we were given data before August 2024, we're going to do forecasting on from that time to September 2025. And we can see that in our prediction, the trend is going to be like in general increasing, although there are some fluctuations between different months. Oh, in our anomaly detection with Profit, we basically used uncertainty intervals output by default of Profit, and we classify the points where there are more than $2,000 deviated from those uncertainty intervals to be anomalies. And here are the anomalies plotted in a plot and also listed out in the dates and their total cost.
Yeah. Even though Profit has already do a rather good job, we were considering how we can do like better job through using like different models. And we try to use a more promising model, which is LSTM, the long short-term memory networks, which is like more capable for learning long-term dependency. And we choose this model because it's good at like capture general trend of the data and also handling complex pattern of this like time series data. And we will first use it to do the prediction and forecast. And as you can see from this, the LSTM model actually do a very good job in like the prediction and like forecasting the future cost. The red line is the forecast for 2025, and actually it's doing a like too good job that it's even overfitting the data. And like clearly we don't want it to be overfitting so that we couldn't get a very general forecast about the future. So we plan on doing like model refinement by reduce like overfitting. And here you can see the arrow is like too small and we want to make it like reasonably larger but still within a very small range. So the thing we do to reduce overfitting here is do data smoothing, dropout, L2 regularization, and early stopping. And all of them are just like techniques I use in the model to reduce overfitting and penalize our model complexity. And after doing that, we get this new model, like a refined model, and do the new training and prediction. As you can see, right now both the training and testing prediction are like the orange and green lines capable of capturing the long-term trend of the data, but well, it doesn't simply just predict on the existing data. So the prediction and the forecast is more general and it's like avoid to be overfitting. And we can see the prediction about the future is generally smoother and it's reliable. So we think with some more fine-tuning, the LSTM model can be more promising in doing the focus. Yeah, and you can see the loss is a little bit larger than the overfitting one, but still within a very small, reasonable range.
For anomaly detection, we use Profit as like the baseline model and explore training and LSTM model since it can capture more complex relationships. So how it works is that the LSTM model is gonna first predict the total cost of the next time step, and it's gonna calculate the loss between the predicted and the actual total cost. And the model will flag the data points as anomalies if it exceeds the loss. And before training, since our data set is not labeled, which means that our training will be unsupervised and so the model training will be dependent on learning the underlying patterns of the data. And since we don't want the models to learn like the outliers. So the first step is to remove the outliers. And as you can see in this graph, there are a few outliers in the graph, and we use the results or the anomalies that the profit model detected, and we remove them from our data set. And next slide. And yeah, and after removing the data, the trend of the total cost looks like this, and we use the clean data set to train the LCM model. And since we're curious about the intrinsic data patterns and on the surface level, so we did some data aggregation and some feature engineering because we don't have a lot of variables. So we added the year, the month, and the day of the week for the data set. So in hopes that the LCM model will be able to learn some patterns among those variables. And since LCM model requires some scaling for stable training and faster model training convergence, and our data is not normally distributed, so a very common method for the scaling is to use a min-max scaler, which scales the total cost within the range of 0 and to 1. And for the loss function, we chose to the mean squared error because this is it penalizes large deviations, and since one of the cons of the mean squared error is that it may be sensitive to outliers, but since we remove them, it allows us to compute like the loss faster. So we chose MSE as the loss function. And for the threshold function, after a few like experiments, we noticed that the distributions of the losses are mostly normally distributed. So naturally, we would want to use standard deviations above or below the mean as like the threshold for the anomalies. And after some tuning, we realized that the 2 standard deviations is the most optimal results. And since we spent a lot of time figuring out how to manage our data, so we only had a little time at the end to perform the LSTM model tuning. So, but as of now, these are the results for the top 3 services. And as you can see, there are certain data points that the LCM model should have flagged as anomalies, but it failed to capture those, and same like vice versa. And but if you go to the very end, BigQuery, for the results for BigQuery look a bit more promising. But if we had more time for the model refinement part, we believe that we could give more promising results.
Finally, our recommendations and next steps. We recommend Dexcom to enhance their budget planning and optimize the commitment using the prediction given by the profit and LSTM models. Also, we recommend Dexcom to do anomaly detection regularly. The next steps for Dexcom is to refine the model and anomaly detection by updating with the latest data, feature engineering, and tuning parameters. They could also try to predict the cloud cost per service, project, or SKU. Thank you.